Alrighty, well, you will recall that we've been investigating how Millikan solves some problems with things moving around and stuff like that. Oil, yeah. What's the density of oil, Chris? The number.
I'm supposed to write that down somewhere.
Anyone? Density of oil? How much? No, I didn't hear the number correct. 800, right. Right you are. 800 kilograms per cubic meter. Density of oil is 800 cubic grams per, 800 kilograms per cubic meter.
Kilograms per cubic meter.
Cubic meter, 800. Okay, so Millikan observed a droplet of unknown charge. Now, this is exactly what Millikan was trying to do. Figure out the charges. Accelerating at minus 2.3 meters per second squared. He determined the mass of the droplet to be 5.3 times 10 to the minus 6. The electric field strength at the time was 3.6 times 10 to the 6. What charge was on the droplet, and how many elementary charges was this? What charge was on the droplet? Okay, I'm going to draw a picture. We've got an electric force going up, and we've got a weight force down. Now, which one is bigger? Can you tell? And I don't mean by looking at it, because I didn't draw it to scale. Can you tell from the data that's given?
No.
Which way is this oil droplet going?
Down.
How do you know down, Mike? Negative 2.3. So in other words, the weight force should be,
5.3.
oh, well, let me do it. The weight force has to be greater than the electric force, right? Because it's accelerating down. If there was no weight force, or sorry, if there was no electric force, it would be minus 9.8. Okay, so can I figure out the weight force? I think I can. Weight force, mass times gravity. So that's going to be 5.3 times 10 to the minus 6 times 9.8. 5.3 exponent minus 6 times 9.8, or 5.194 times 10 to the minus 5 newtons. I should be able to, now do you remember me rearranging E equals F over Q? Whoops.
Yeah, I don't like that.
You don't like it this way? Okay, I won't do it then.
Yeah.
No problem, I'm here to please. E equals F over Q. The electric field strength is 3.6 times 10 to the 6. Solve for force. Oh, hold on. Hold on there, buckaroo. I'm trying to solve the Q, aren't I?
Oh,
I don't have the force, do I? I got two unknowns here. Oh, we can. What do we know? We know that it's accelerating at minus 2.3. Is that not going to give me my net force? That's going to give me the net force, isn't it, right? So let's just do that. The mass is 5.3 times 10 to the minus 6. The acceleration is minus 2.3, giving me a net force of, did you get, I'm hoping you guys went ahead and did this, 1.219 times 10 to the minus 5. Okay, so now what's my next step? I got my weight force, I got my net force. Can I use that to find my electric force? Isn't the net force simply these two added together, right? So if I know the answer to those two added together, I should be able to figure out what that one is right there, right? So my next step is to write something like F net is equal to Fe plus Fw. The net force is, and now is this minus important here?
Yes.
Yes, it certainly is. We're solving for the electric force, and the weight force is minus. Now, should this be a negative right here? This 5.194?
Yeah.
That should be, right? Yeah, that should be negative there. And it's important that it is, because it's going to matter here, right? So this is minus 5.194 times 10 to the minus 5. So my electric force is, now, do I have to show this for you guys, or can you mentally sort of take that over and make it positive?
No, you should.
I should show that. So it's going to be 5.19 times 10 to the minus 5 minus 1.219 times 10 to the minus 5. It's all these big crazy numbers that make it hard, isn't it?
Yes.
Yeah, I know.
It's confusing.
.97 times 10 to the minus 5. That's my electric force. Now, should it be positive?
Yep.
Absolutely, it should be. How come, Chris? Because it's going up. Absolutely, it has to be positive. It's going up. Now, I should be able to take that and plug it into this one way up here. Now, should I just leave this way up here? Or should, like, from a standpoint of doing a solution, should I just leave this way up here?
No.
Probably not. I should probably do what? Just, well, either move it or just sort of rewrite it down here, right? Here's where I'm going to go. E equals F over Q. It's long. 3.6 times 10 to the 6. Yeah, I agree. 3.97 times 10 to the minus 5 all over Q. That's a Q, not a 9. How can you make a Q not look like a 9?
Put a little tail.
You could put a little, yeah, you could make it a capital. It's probably not the best one. Yeah, a little tail there is usually the best way. Q then is
Q for quit.
3.97 times 10 to the minus 5. This is going to be big, isn't it? 3.6 times 10 to the 6. Oh, it's going to be tiny, yeah, tiny. 3.97 exponent minus 5 divided by 3.6 exponent 6. 1.1 times 10 to the minus 11, and that's going to be in coulombs. I'm just going to pause there for a second. Just going to pause it. All right, so I got a charge of 1.1 times 10 to the minus 11 coulombs. Now, I believe, am I right, Mike? Does it say in coulombs, or does it say how many elementary charges is this? Remember, this is what Millikan really was trying to find out.
Wow,
Right? So I would prefer that you set up a little ratio that shows something like this. One elementary charge is equal to, anybody remember what the number is?
1 L equals 1.6
Times 10 to the minus 19. So how many Elches, X Elches is 1.1 times 10 to the minus 11.
minus 19.
Yep. Cross multiply, and you're going to end up with 1.6 times 10 to the minus 19 times x, so you're going to be dividing by that, right? Basically, all it is 1.1 times 10 to the minus 11 divide by 1.6 times 10 to the minus 19.
And that's a really small number.
Yep. Well, no, this is going to be a big number.
No,
This is going to be a huge number.
not even. Oh, okay, this is what.
Yep.
The minus all the things.
6.9, we'll say. 6.9 times 10 to the 7 Elches. That's a lot. That's a lot.
It's enough to rip your arm off.
Now, I want to point one thing out because I haven't really gone through. I do want to point out one thing here about this Millikan stuff. One of the things that he had to do was he came up with, like, he didn't know this number. This is the number he was trying to find, right? So he found a whole bunch of these kind of numbers, 1.1 times 10 to the minus 11 coulombs. He found much smaller versions of that. Okay, like much smaller. But he noticed that the numbers that he was getting for charges were never smaller than a certain value, and they were always multiples of that certain value. Do you understand what that means? Did you read that at all in any of your reading?
No.
No? Okay, because that's kind of a key point. Okay, so let me just give you an example there. Let's say that the charges that Millikan found, and I'm going to simplify this for you so you don't have crazy scientific notation. Let's say that the charges that he found were like this.
These classes hard.
Would be multiple, right? Right.
Okay, let's just say that he found that many charges. They're never smaller than what?
1
0.8. They're never smaller than 0.8, and they're all
plus.
multiples of 0.8, right? 0.8 goes into them all. So in other words, how many elementary, what's the value of my made-up elementary charge here? 1 Elch in Bennett's world is equal to 0.8. This is 1 Elch, this is 2 Elches, this is 4 Elches, this is 3 Elches, and so on. In other words, 1 electron in Bennett's world has a charge of 0.8 coulombs. This is what Millikan did 100 years ago, but he did it with 1.6 times 10 to the minus 19. He realized that every charge was never smaller than that 1.6 times 10 to the minus 19, and they were always multiples of that. In fact, what he probably did was he probably graphed them, and how would you know that they're multiples? What would they look like? They'd be a straight line, wouldn't they?
Would be so hard.
In fact, if he found the slope of that line, it would give him his elementary charge. He did that all without a calculator and a computer. That's pretty impressive.
That's very smart.
He
Maybe
spent more than 5 minutes playing, and I don't think he checked his Facebook account at all during that day.
maybe you just got lucky.
Maybe. All right. So you should now have, I think on the back page there, am I right here, right? Those questions on the back? Yes, I am right. Now there's only 6 because they're hard to make up. Okay, so I would encourage you to take your time and go through those. The answers are there right below you. You can check your work. I have one more thing to discuss with you tomorrow, but the test is tentatively scheduled for Friday. We will determine that for sure tomorrow.
I'm interested.